Hello and welcome back to another demo of Influence for Desktop. Today we're going to be demoing a pretty common use case and a way of using this application to solve a relatively common data science problem, which is how to identify and remove outliers from your data such that you can have a clean and accurate data set for training your models. So we're going to solve this problem in two steps, pretty simply. The first is verifying that we do in fact have outliers in our data and then removing them, or rather marking them such that they can be removed, and then we'll be applying a filter query against our table of data with the marked outliers to remove them from the data. So pretty simple. So without further ado, we'll go ahead and get started. And I've already initiated a new project here within the application. So I will go ahead and start at square one, which is let's grab our data. So I have this saved in a CSV, and I'm going to be using the Iris dataset to keep this nice and simple for folks who are familiar with the dataset. I have not named the headers, so I'll pull this in, run it, and let's go ahead and check out the data. Sure enough, so pretty simply, the attribute column 0, 1, 2, and 3, and the label column is column 4. Only one table in our data set right now. Great. So now what we can do is head over to Analyze, and you'll see here there is this tool here, LOF Outliers. That stands for Local Outlier Factor, Outliers. So I'm going to grab this tool and drop it as the next block in our workflow. Open it up and let's check it out. So the first thing we do is we need to select the table and the data in the table, or the columns in the table that will make up the data on which we're trying to identify outliers. So for this, it's all of the attributes. So I'll just say select all, and then I'll deselect column 4, which I know is our label column. I'm going to keep the Euclidean metric as a distance measurement, which means that I'm going to want to leave the Minkowski metric as 2. You can see here, if we're using Euclidean distance, we want to use a Minkowski metric of 2. If we're using Manhattan, we want to use it as 1. Great. So it also will execute a k-neighbors query in the background. So we have to define our number of neighbors. I'm not going to get into too much of the details of how to pick the appropriate number of neighbors. This is using the Local Outliers Factor algorithm, so you can do your own research on how to do that. But I'm just going to pick 5 here. And I'm going to tag outliers with the name outlier. And then I'm going to tag non-outliers with the tag non-outlier. And I'll leave this column name as outliers. So this is where our tags are going to go. Fantastic. So I'll save this, and it looks like we're ready to go. So I'll run it. All right, that finished successfully. Let's look at our data. All right. So it looks like we found a few. Pretty easy so far. Not a lot, but there's some in here, which is fantastic. So that means that we can go ahead and parse these out. So let's first look at the table properties here. Just check the number of records we have, 141. Great. And now it's time for us to filter the outliers out of this data. So if we go to the Transform tab and we grab, as you would expect, the Filter tool, we'll drop this into our workflow, Configure. We only have one table, so that makes it easy. And now we have the opportunity to try out the filter builder. So we need to add a clause to our filter, and we only need to add one. So this is going to be pretty easy. Say add clause, and we want to pick where outliers is not equal to outlier. And because this is a string, we do have to wrap it in quotes. No need to mess around with parentheses or anything like that. And we should be good. So I'll save this. Run it, and our data is now free from outliers. Check the properties. There's looks like we removed 5 records. If we scroll through this real quick, I don't see any outliers. We are good. So now we would be good to go ahead and use this data to train our model free from outliers corrupting or otherwise infecting our data set. Thank you very much for watching this demo, and